So section 2, what we're going to talk about and the goals and objectives for this section is to hopefully have a better understanding of what exactly functions are. So the idea is to get a better grasp of what functions and what the graphs of functions will tell us. So what we need to first define is what exactly a function is. And to define it very quickly, what you need to know is that if you have two sets of whatever, a function just takes one set and maps it to another. So if you have this set of numbers, which we're going to call the domain, a function takes with some rule and maps to the other. Okay? It's going to be some rule. Whatever the rule is, the function is going to take and map from one set to the other. And what the domain is, it is the set of all numbers used by the function. Okay, it's the set of numbers that the function can use. Okay, the function can use these. Okay, so whatever the function is, it's all the numbers that this function can use. Okay, it's called they are also called inputs for a reason, because it's what you can put into the function. Okay, the range is all the set of numbers created by the function, or the rule, or the output, or what you get out of this function. Okay? So if you think about it, whatever you have as a set of numbers, let's say it's 1, 2, and 3, those are the numbers that you can put into a function. This rule is going to create a new set of numbers. Let's say it's 4, 5, and 6. It's very basic, but you are taking numbers by some rule. You are creating a new set of numbers. It might be the exact same set of numbers. You might be able to put in numbers and you get back the exact same set of numbers. You might put in this same set of numbers and you get always the same number. And we'll talk about what makes a function unique and how it makes something a legitimate function and so forth. But all a function does is it takes numbers and maps them to some other set of numbers by some rule. The rule can be anything that you can create, but in order for something to be a function, okay? In order for something to be a function, this is what's key. No value in the domain can go to multiple values in the range. Okay? So to think of this as a picture, let's take a look at this. Let's say you have 1 and 2. I'm going to use two different numbers. If you plug in 1, I'm going to get 5. If you plug in 2, I'm going to get 7. Not a function. 1 and 1. Plug in 1, I get both 1 and 2. This is not a function. So to think of this in a practical example, and I'm going to use a cooking example. If I put in all the recipes or all the ingredients for chocolate chip cookies and I put them in the oven, I'm going to get chocolate chip cookies. I can't do this the exact same way and then get blueberry muffins. It's two different things. So if your function produces two different things with the same value, then it's not a function. It does two different things with the same value. You can't put something in and expect to get cookies and muffins from the same thing. So this is not a function because it does two different things with the exact same value. Okay? So that's what makes a function versus not a function. Okay? Now, in this book, and when you get to calculus level classes, you have to be able to define things very quickly in terms of what works and what doesn't, because sometimes some values work and sometimes an infinite number of values work. And way back from college algebra, when we talk about an interval of values that work, we use interval notation. So if we're talking about a set of numbers that can work from A to B, this looks like this. On a number line, that's how you would write it. Anything between A and B, but including A and B. In interval notation, when we learned this, we would say that this is this set of numbers. That's what interval notation looks like. You create the two endpoints to define what you can include with your domain or range or whatever. Now, let's suppose you don't want to include those 2 points. So we have everything from A to B, but we don't include them. We just use open parentheses. So this should be review. Now let's suppose we have it the other way. Let's say we have it going this way. Now, this way it means it's going and not stopping towards negative infinity. And that means that it's just continuously decreasing without stopping. This way it's going towards positive infinity. So we actually have an interval here and here. You can never reach infinity. This is why we have a open bracket here for this one. But the way this would look as an inequality is you have to be less than A or greater than B. So this is interval notation. And you might say, well, there's two intervals. How can I say one or the other? You put a big U in between them. Now the only difference between this and these brackets is the symbol that you use. You would have the infinity sign and you would use close brackets instead. Okay. Now, lastly, let's suppose you just want to exclude one value. Let's just say I want everything except A. So you just want one number that you can't include. It might be the best to just say you can't have that value. But you can write this as an interval notation. And the way you would do it is like this. Because you're going from negative infinity to A and from A to positive infinity. And this is how it would look in interval notation. So you have to describe your intervals in terms of what bounds them, the boundaries from the two numbers. And these just mean that it increases or decreases without stopping. Okay, so from this first part, what we have talked about is specifically what defines a function, and more specifically how you define the set of numbers and an interval of numbers when you're describing the numbers that work for a function. And in the next video, the objective is going to be how you take a look at a graph and use this type of notation to describe domains and ranges. So we're going to combine these two things in the next video.